and it'll save whatever it is. I'll change the name later, save time. All right. Here we go. So let me grab my chair. I don't like sitting down, but it is useful sometimes. All right, so today is Geometry Notes number 1, logical reasoning. All right, so we're going to talk about 2 different forms of reasoning here. And when I do this, I need you to really think about what these things mean and what the difference is between them, right? You do need to know this stuff. That's why I bring it up. So think logically. Use your reasoning when we're going through this stuff, right? 2 different things, they should have 2 different ideas. That's all the clues I'm going to give you. So inductive reasoning, inductive, is using examples and evidence to construct a conjecture. So pause. Word we don't know. Conjecture. What is it? Anybody have an idea of what it might be? Nobody wants to conject about a conjecture?
That's all I have.
Yeah. The visual? All right, we have this visual going on here. All right. So, for those of you following along at home, a conjecture is an educated guess. It's like a hypothesis in a science class, right? It's something where you have this evidence and you're like, ooh, I see a pattern. I think I see a pattern. Maybe it's the one that's not divisible by 3, right? Oh man, maybe it's wrong. You find out later with new evidence, a counterexample, right? Or maybe the evidence keeps piling up and you think, man, this is a really solid conjecture, right? That's still not enough to prove it. You can't say, oh, it works in every case. You can't prove every case, right? You have to use some reasoning to get there. But a regular conjecture can be like, man, this is really convincing, right? It seems like every other number is odd. Oh man, I can't prove that, but like, it really looks like it should be. That's conjecture, okay? We're going to be making conjectures all the time in here. When you raise your hand, you have something to say, that is conjecture, okay? So, constructing a conjecture with inductive reasoning, okay? Inductive reasoning says 1 squared, 3 squared, and 5 squared. 1 squared is 1, 3 squared is 9, 5 squared is 25. So this is my evidence, right? My examples and evidence right here. So I say, thus, all odd numbers produce odd numbers when they're squared. I really need to sit down so you can see. I need to move this desk over. All right, so if it's odd and you square it, it produces an odd number. That is my conjecture given the evidence. You know, we can go further. 7 squared is 49. 9 squared is 81. It seems to make sense, right? So here's my conjecture. All odd numbers produce odd numbers when they're squared. An example I have of inductive reasoning is that I know that student 1, student 2, and student 3 like math. How do I know that? Well, I just gave it to you. You have to trust me. Maybe you can make a conjecture about how I know. Their parents named them student 1, student 2, and student 3, right? Which is probably a good indication that they like math. All the numbers in their names. Therefore, I love that word. All students like math. So I took a survey, and student 1, student 2, and student 3 all like math. And so I said, oh, well, that's enough to conclude that all like math. Is this conjecture true? Maybe, right? We can't say it isn't, we can't say it is. It might not be, right? I asked student 4, and they're like, no, screw math, I hate math, right? Or maybe we ask student 4 through student 1,000,000, and they say, yeah, I really like math. But 1,000,000 isn't all, right? There should be infinitely many students in this math world that we're in. So it's not necessarily true. Conjectures, again, are more like educated guesses, okay? But they need to be really educated. We make them through inductive reasoning. Deductive reasoning, using true statements to imply another statement is true, okay? So we're taking true ideas, and then we're going to go with a big therefore, this must be true, okay? So this is Sherlock Holmes at its finest. So here's the example I give you. I love this example, okay? Because I'm a vegetarian, right? You guys don't know this about me, but I am, okay? And so therefore, if I'm a vegetarian, I must love salads, right? That's the logic everybody else uses. That conjecture is wrong, by the way, okay? But you don't want to know what my favorite salad is? Here we go, okay? So my example is salad, highlighted in pink. So that's idea number 1. Salad, and then the definition of salad is in yellow. So salad, by definition, is a mixture of an ingredient and a liquid dressing. This is true, no one can deny it. Do you agree? Salad is an ingredient plus a liquid dressing, right? Okay. Cereal and milk, that's in red because it's a new idea. And here's the definition, yellow. Cereal and milk is a mixture of an ingredient and a liquid dressing. You might disagree with that, but you're wrong, okay? It is. Now notice, both are yellow because they're both the same dumb thing. I didn't have to write this a second time. I could have done the quotations thing that we did before, right? Same dumb crap. Could have saved a lot of ink. So why didn't I? I didn't because I want you to see that these are the same thing, and you have to be able to see that yourself without being told that they are. So if they're the same thing, then these should be the same thing. You see how I took 2 logical statements and kind of fused them together? If that is that, and that is that, then these must be each other. If the ball is red, and my hat is red, then they both must be red. If salad is a mixture of an ingredient and a liquid dressing, and cereal and milk is a mixture of an ingredient and a liquid dressing, then salad and cereal and milk must be the same thing. Therefore, cereal milk is a salad. It's my favorite salad. It's my favorite salad. I order the salad all the time when I go out to eat. You know what my favorite version of the salad is? Honey bunches and oats. The ones with the strawberries. It's good stuff. Now, they don't put enough strawberries in there. There's a lot of honey and bunches and a lot of oats, but not a lot of strawberries, so I add extra. It's my favorite. Thanks for asking. Turn the page. Notes number 1 continued. We've got some symbols. I love these symbols not because they save you a lot of time, which they can, some of them more than others, but because these symbols are like the thing you see in math class and like in movies where they're writing all kinds of stuff and it's like, oh man, he's a scientist, right? And so when I write this stuff, you guys think, oh man, he must have gone to college, and you're like, not right about that. I sort of did, but not really. It's a long story. I don't really have a math degree. This is a fun story we should get into sometime. I play a math teacher on TV. Okay, it's just acting. None of this is real. So we're going to write these symbols to make us look super smart. Because that's the whole point, right? Keeping up appearances. You don't have to be smart. They'll hire you if you look smart. Get some glasses, wear a nerdy shirt, write some symbols. They don't ask about your degree. All right, so this right here is an arrow. Poorly drawn, but it isn't, okay? And it's a thick arrow. We're going to talk about that later. Thick arrow means implies, okay? There's directionality here. A implies B, so A is driving the bus, right? If A is true, then B must be true, because they imply each other, right? Now notice this doesn't go both ways all the time, unlike love, which should. And if it isn't, you're in a relationship like that, you need to cut that off, okay? So, one implies the other, it's a one-way street. There are sometimes where it goes both ways is love, okay? A if and only if B, right? You love them if and only if they love you. Love is something that needs to be reciprocated. If it's not love, it's creepy. Or, okay, it's just not reciprocated and you need to get out of there, right? Dump his butt. So, example. Today is Friday implies if and only if tomorrow is Saturday. So today is Friday if and only if tomorrow is Saturday. If tomorrow isn't Saturday, then today cannot be Friday. Do you see how they kind of go together? They're a team, like peanut butter and jelly. Or what's another good one? Like Mario and Luigi. Give me another team. Dynamic duo, power couple, come on. Batman and Robin, give me one more. Jordan and Pippin. You were born in like 2003, so you have like no idea, but like, yeah, pretty much. So, example, 2 implies even. This is true. If I say 2, right, if it's a number up on our example, right, you're going to know, oh, that's an even number. It's divisible by 2. That's what even means, definition of even. So 2 must fit it. So 2 implies even. But it doesn't work the other way around. If I say an even number, it doesn't imply 2. It can imply 2, right, because 2 is an even number, but not always. If I say, hey, I'm thinking of an even number, you aren't going to go, easy, you're thinking of 2. Could be anything else. I'm like, no, I was actually thinking 28. Okay? It doesn't go both ways. This is not love. It is not reciprocated. Again, reciprocated is a very important word we're going to be talking about this year. Reciprocate means to return. Other symbols. Okay? This one's one of my favorite, the upside down A, because it just looks so dope when you're writing out math stuff. Okay? It saves you so many letters, too, right? So it's not a big time saver, but it looks really cool, right? So that means all. So like all students, I would do with that upside down A, all students, right? Contradicts. This is a fun one, right? You got like this and then boom, elbow, right? The people's elbow. Anybody about that, right? No? WWE? That's right. The Rock, do you smell what is cooking? So contradicts means that there's 2 things that can't be true. They don't work together, right? If one isn't true, the other, right, they're in conflict. So this is like when your parents are like, hey, don't do that. And you're like, okay, mom and dad, and then they go do it and they're hypocritical, right? They contradicted themselves. And I bring this up because I can't relate to you guys anymore, but they told me if I talk about how parents are dumb, you'd be like, yeah, fight the power. And we'd be like friends, right? Is that how it works? No? Okay. So contradict. Speaking of parents, I don't have any. Okay? So I don't have any. And you're wondering, why? How does he not have parents, right? How does he not? Okay? Well, I'm not going to explain that. Not. Okay? It means it's not true, so it's the opposite. You're worrying about these parents, aren't you? Okay, I'll talk. You're still worried about parents. I saw my parents last weekend, okay? And they weren't in graves. I just contradicted myself, right? I do have parents. That's what a contradiction is. Do you see that setup? That was amazing, right? That was beautiful, right? Got him! Not! That's what you guys do when you're being like super edgy teenagers, like all the freshmen in here, right? Oh, that's real cool. Not! Right, that's you, Danny, right? We all know it. So that's the symbol right there. You can go like this. Not! Right? Actually, hold on. We want it this way, right? That's the symbol. So if you're talking to math people, you want to bust this one out, and if you contradict, boom! People's elbow, right? The and symbol, right? That's not what it's called. Who remembers what it's called? What is this symbol right here? I swear to God. What is it? Remember the first day of class? Remember how traumatic that was? No. Psychological scarring is a valid form of education. You'll never forget. Right? That's what psychological scarring is like. Ask me, okay? So I thought I starved you guys to the point where you wouldn't forget what this symbol is. What is it called? It's not and. Right? Remember I did the W thing, like, what is the symbol? And you guys are like, W. I'm like, yeah, no one would say it's the W symbol, right? It's how you pronounce it. It's the name. All right, 100 points, whoever gets it. Just like whose line, everything's made up and the points don't matter. Nobody? Good guess, but not quite, okay? I love when I say like things like, oh, there's no wrong answers, and then somebody says something, and I go, man, I have never been proven wrong so quickly. All right, so this is the and symbol, also known as the ampersand. Can you guys see that? Ampersand. So again, that's a terrible one. It's an 8 with 2 tails, which is probably sinful, but I would argue it's progressive. So that's the and symbol, also known as the what? Ampersand. Good job. All right, let's go down here. Backwards, capital E. This is a cool looking one. It means there exists, right? There exists a solution to this problem. You wish there was. A lot of problems in here, there aren't going to be any solutions. The real question is going to be, why aren't there any solutions? And how can you prove that there aren't? It's very meta. No solution. All right, there is no solution. The limit does not exist. All right, E with going forward, it's got like a curve, right? Again, we are body positive in here. So it says is an element of exists in. Okay, so this does save you a little bit of space, right, if you're writing this thing. So elements, what are we talking about? We're talking about groups. So this school is a group. Inside this group is this classroom. This classroom is an element of the school. It exists within the school, right? Like physically, actually, right? You guys are an element within the classroom. So we have a Russian doll situation. We've got the big group, the school, the medium group, right? Mama bear, Papa bear, baby bear. You remember the protractors, right? Protractors being the farm and fleet. We've got the big school, big group, and then inside that group we have a smaller group, smaller doll, if you will. That's the classroom. And then you guys are the smallest of all the dolls, right? Right? So you are the smallest element within that school, okay? But you all exist within it. There exists a student within that element, right? Or within that group. You are an element of that class, okay? So maybe a number is an element of a certain group. We're going to talk about different groups of numbers on the coming pages, okay? So we have there exists, backwards E, ampersand, the and, right? Not, we don't see that one a ton in here just because we don't do a whole lot of symbolic logic like that. All, which I use all the time. Got him. All right, so contradicts, right? People's elbow. And then we've got curvy E, we are body positive. There exists, okay? So here's an example with it. What's that symbol mean? All polar bears are left-handed. Anybody left-handed in here? No one cares. 10% of car thieves are left-handed. What does this symbol mean? I didn't cover it. What is it? Therefore, you read. Good job. All right, so that's a triangle-looking thing, just without the lines. It's the dots. I love therefore. It is the best thing, okay? You do all this stuff, you're looking really mathy, and then at the end, therefore, boom, I'm awesome, right? I mean, that's math right there. So therefore, there is a 10% chance your car was stolen by a polar bear. Polar bears are all left-handed. This is very simple logic. Follow with me. Polar bears are all left-handed. 10% of car thieves are left-handed. That means there's a 10% chance you're a car thief with the polar bears, right? I'm using what kind of logic here? What kind of reasoning? Inductive or deductive? You can look in the notes if you want. What kind of reasoning was that? Inductive. Why? I know. Everybody has answers, but they don't know why. I want to know why. I said what?
You said therefore, which means you're like proving.
Interesting. So he says therefore means we're proving something, which means it is which one? She says inductive. What do you say?
Deductive.
You say deductive. We got a fight going on here. How about you?
Deductive.
Deductive. We got another vote for deductive. Fight. I told you about the principal coming in when I was yelling that one time, right? I don't want to do that again. What? Okay. So here's the thing. Remember when I prefaced this whole thing with saying, hey, we're going to talk about these two things, and when we think about the difference between them, you don't actually know the difference between inductive and deductive, do you? And I wrote it down in the notes, and you believed it because it's in color and it's in permanent ink. You wouldn't write something down that wasn't exact, right, and perfect and great for us. You naive fools. So here's what you're going to do. Part of your homework is going to be to figure out the difference between inductive and deductive reasoning. My definitions are fine, but they aren't juxtaposing each other. They aren't in contradiction, if you will. People don't, right? So you need to figure out the difference. And that's not something that's going to be in a worksheet. I want you to figure that out at home. I need little Chromebookies, right? Figure it out. Turn the page. All right, let's talk about sets. Again, I alluded earlier that we are body positive in here, and we are. Okay? Look at these letters. Dang, she's thick, right? That's thick end. Okay? Right, we got some curves down here on this Q. Love me some of that. All right. Math is sensual sometimes, guys. It's okay. It's all right. Don't repress. All right, so this symbol right here is thick N. You want to know how to draw it? Of course you do, right? You're like, I'm going to go home and draw that. All right, here we go. As long as you do it in the privacy of your own home. We have a stick, right? And another stick. So far, normal N. But what makes her special is we go back to the beginning and hit it again. Oh, yeah. Now that's nice. Dang, son, right? NSFW, right? Like, I don't know. All right, so there's our thick N. Now notice this thick N has a little subscript down here. We say subscript because the superscript goes up high, right? Because like Superman flies. By the way, Superman sucks. The little script, the one that goes down here below, we call it a subscript. Okay, so that's Sub-Zero, like Mortal Kombat. Finish him, right? Now we're crossing the streams here. I don't want to send the wrong message. All right, we got thickness and finish. All right, so here we go. We've got this. This is called N sub-zero. Okay? So when my old math teacher, Miss Fraley, would say this really fast, unlike me, who speaks very slowly and very clearly, okay? She would say N sub-zero. And I would think she was saying N of 0, and that's not true. N sub-zero, sub because it's a subscript, okay? So it's a special version of thick N. It's not just regular thick N. We got a little bit extra, right? So this is N sub-zero, which stands for the natural numbers starting at 0. So what are the natural numbers? Well, the natural numbers are the ones you count your sheep with. Your cows, right? Smell what I'm stepping in here? Cow town? Yeah? Podunk? Okay, so if you're going to count your cows, you're probably not going to use -7 to do so, right? At least I wouldn't, okay? Or root 2 or pi. Right? You're probably going to use numbers like 0 cows, 1 cow, 2 cows. They're natural numbers, right? En natural, okay? I'm talking organic here. Starting at 0. We also call these the whole numbers because somebody thought we needed a whole different name. Get it? Whole. A whole different name for a set of numbers that just adds on 0. Because the natural numbers, N sub 1, right, starting at 1, it's the regular natural numbers. Bad, your sheep, right? Dang, sheep think, bad. All right, so starting at 0, we add on one more number. It becomes a whole new, the whole numbers. Get it? Yeah. Okay. Oftentimes we'll say whole numbers. It just means all the natural numbers plus 0. Okay? An example. Here's a set of natural numbers. You like curves? Here they are, baby, right there. Those little brackets, those curvy brackets, mean that's a group or a set. Okay? So here's the set natural numbers. Whole numbers, really, because it has a 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, and on and on and on and on. Okay? No yawning in my class. Z! Okay, so mathematicians are stupid. This is the set of integers. And you're like, oh, N for natural, Z for integers. Wonderful. They took the N and turned it on its side. Why did they do that? Well, here's why they did it. Because if you've got a number line starting at 0 and going on, you know, we got 1, 2, 3. What's the next number? 4. Great. You guys got it. Wonderful. Excellent. Okay. If we take that number line and we flip it, remember, we're starting with N sub 0 here, right? And we flip it, what happens? Well, we flip it. And now 0 stays here. We're rotating about 0. We get -1, -2, and -3. So the integers, which is N on its side, is a rotation. It takes the number line and flips it across, and it makes the opposites, the negative numbers. You learned about these, or at least you pretended to learn about these in middle school, right? When they first introduced negatives, and you're like, dear God, why? Okay? No, dear God, Z. So these are the integers, and they go on in both directions. Risque. Q. What starts with Q? Rational, of course. Really what it means is quotient, and quotient means division. And what is division? But fractions. This is a comparison of numbers, okay? How many times does 2 go into 6? Well, it goes into 3 times. That's division. Another way to say that is 2 compared to 6, or a ratio. So when you say rational, really what we mean is ratio of numbers. Fractions. 1 out of 3, 1 out of 1, -3 out of 5. Hopefully that's not your batting average. 2 out of 7, right? These are comparisons. So these are rational numbers. So any number that can be written as a fraction is a rational number. So not only does it have these fractions, but it also includes the regular numbers, the natural numbers, right? Because 1 over 1 is just 1, right? So we have this big group of rational numbers. The smallest group we know is the natural numbers, right? It's the most selective. You can't get in unless you're very specific, okay? Integers opens up the field. It doubles it, doesn't it, right? It adds on the negative. So a little bit bigger group. The natural numbers still exist inside that. It's a little bit bigger, right? And then even bigger, we get the rational numbers, okay? And that expands it even further to add on the weird ones like 3/4, you know, the ones that you guys absolutely hate. You won't after this year. I'm going to teach you how to think about fractions. We do it a really stupid way the rest of school before now, but it's just division for lazy people. You're going to be okay, I promise. I know everyone's been saying you're going to get fractions this year. It's going to be fine. You really will. You really won't. I didn't until I started thinking about it this way because I sucked at math. Same thing with both my students. You're going to get it. Then we have the real numbers. This is the biggest of all the sets that we're talking about right now. The real numbers are all the numbers that you might use on a daily basis, okay? And by daily basis, I mean in a math classroom. They add on numbers like root 2 and pi, right? But it also includes the ones we saw before, right? So it's a bigger set. Again, think Russian dolls, right? The biggest doll contains all the others, right? So all the numbers that you're aware of are real numbers. And again, that's thick R. Oh, that's a nice one. You want to know how to draw that one? There you go. Thick R is 2 sticks. Boom! Dang! Now we got to balance it out. All right, there we go. There we go. Look at that. Look at this right here. Bam! Shouldn't be teaching this in school. You guys aren't old enough. Do you guys have permission slips signed fast? We need to get those out. Your parents have to be okay with. I know some religions aren't. All right, so here we are. Now notice something about these ones, right? All the ones before were thick with multiple C's, right? At least 2, okay? What about this C? Does this C have multiple C's? No, it's not. It's thick, it would have 2 C's. It wouldn't look like this. It would look like this, right? We're not talking this. We're talking this. SpongeBob and Patrick, right? So it's a single thing. It's not thick. So unlike all the other thick ones, it's not a set. It does not contain multitudes, all right? So this is a symbol, kind of like that backwards E we had earlier. What was the backwards E standing for? It's not there exists. What is it? Hold on. I led you astray. It's not the curvy E. That is an element of. It is, there exists. I lied, I'm sorry. Good job, Danny, you knew it. All right, so C means is contained in. So again, think Russian dolls. The set of, what's n sub 0? How do we say that? What set is that? It's a whole different set. What is it? It's a whole different set, yeah. The whole numbers, right? The whole numbers are contained in the integers. This is true. If you look at the integers, right? The integers are these, right? The whole numbers are here, 0 to whatever. So it's with inside that. So the whole numbers are smaller than the integers. Now, riddle me this, kids. How many numbers are there? How many numbers are there? Come on! 10. What? I get one person making that joke, but it's not a joke if everybody says it. Now it's like scary. How many numbers? There are 10. 4. All 10 of them. I can recite them for you. That's frightening. No, there are infinitely many numbers. So riddle me this. If there are infinitely many numbers, and half of those numbers are the whole numbers, how many whole numbers are there? We take infinity, and we cut it in half. Half of infinity. What's half of infinity? 12. All right. Good. Which is more numbers than we've ever had before, because we stop at 10 normally, right? So, it's still infinity. Guys, you know when you're on the playground, you're like, my favorite number is 2. And then you have that one moron who you know his favorite number is 1. But he's like, well, my favorite number is 10. You're like, no, it's not, right? But he's doing it because he wants to have the bigger number. And somebody else comes in, my favorite number is 35, right? And someone else is like, my favorite number is 12. It's like, no one cares, Danny, that's smaller than 35, right? But then eventually you get to infinity, right? And then somebody's like, well, I like infinity plus 1. You ever been there? Well, first of all, those two people are morons. Infinity is a number, it's an idea, okay? And number 2, you can't add numbers to ideas. I would like turkey sandwich plus 7. What is that? That's an idea adding to a number. It makes no sense. It's just as silly as saying infinity plus 1. It's still infinity. It's not a number, it's an idea. There's a difference here. So it's still infinity when you cut infinity in half. What happens when you cut 0 in half? We're going to talk about that later. All right, moving on. So, again, the curves. Dang, son, back to back. This is called a set. It's the group, right? So I have group S sub P. That's how we say that, S sub P. And I'm dating myself here. Charizard, Blastoise, and Venusaur are in that set. What do you think SP stands for? Anybody that follows Pokemon? Oh. You remember when you were like in 5th grade back in 1998 and you played the original blue version, right? You had to pick your starter, Squirtle, Charmander, Bulbasaur. They eventually evolved into this. What is wrong with you? Okay? Starter Pokemon, that's what S sub P stands for. It looks really fancy, like, oh my god, very mathy. No, I came up with that. A mathematician comes up with stuff when they write this down. You can read this now. Starter Pokemon equal Charizard, Blastoise, Venusaur. Down here, V sub D. That's how we say that. Again, sub, underneath. Honesty, justice, and equality. What does V sub D stand for? Well, I made it up. It's values of Derek. That's my first name. So these are sets. And this is the label for the set, the name of the set, values of Derek. What are your values? Turn the page. We're on geometry notes number 2. We're going to zoom through this because definitions are boring. Because what's the point, right?
Oh, that's funny.
Right? Okay, so what's the point? I'm asking a question. Come on, what's the point? Somebody. Popcorn. Oh, you know what popcorn is. A specific location with no dimension represented by a dot. So that dot right there has no dimension, has no space at all that it's taking up. None. But it is a specific location. I know, right? Isn't that wild? It's a specific location, but it has no space or dimension.
So it's just floating.
It's just floating there. It exists, but it also is completely intangible. We call this point P, okay? Line, a continuous straight path with no thickness. Oh, man. But infinite length. So it goes on forever in both directions. Lines in here don't get cut off. They keep going and going and going in both ways. Okay? We label this line as either by its points, line AB. You label it like this with the little arrows going in both ways. That's important. Or we can call it BA, right? Yeah. Or we can, line L, which is usually a low cursive letter. Okay? So you can call it line Q, line 7, not line 7, but line Batman signal, as long as it's cursive. Okay? A plane. You guys were all born out of 2001, right? Wonderful. Okay. So when I do this, it won't offend anybody. Right. So this is a plane. A flat surface with no thickness. Dang. She not thick. But infinite length and width. So we have infinite length in a line. And we have infinite length and width in a plane, right? Now we can label it by its points. Plane XYZ. It takes 3 points to make a plane. We'll talk about that later, why it takes 3 points. Okay? We can also label it by a capital cursive letter, like plane R. Okay? Too soon? Was that too soon? Okay. All right. Seriously, we should actually pay all the firefighters, responders for all the money that we promise them when they get in trouble, instead of holding it back from them and trying to be cheap. Mitch McConnell, if you're watching do something about this. Line segment. Okay? So a line goes on forever in both directions. It has infinite length, right? But no width. A line segment is what happens when you cut it off both ends, right? The Black Knight and Monty Python and the Holy Grail, right? It's just a flesh wound. No one's seen it.
Yes, I've seen that.
Okay, wonderful, excellent. I knew that we would be friends. All right, so line segment CD. Again, notice this does not have the pointy parts on it, right? Because it's a line segment. I'm going to be pedantic. That means really ridiculous and stupid when you call this a line. And I'm like, no. Okay, it's a segment, which is a song of the day by Charles Parker, right? Again, do heroin. We talked about this. Ray, like Ray Charles. Okay, another jazz musician. He was a blind guy, right? And he did the song that you love. Gold Digger? Oh, wait, no, that's the cover. Okay, so Kanye took a little bit of Ray Charles' song, I Got a Woman, way over town, good to me. Right, we'll play it sometime. You'll hear the Gold Digger line. It's great, okay? So that's Kanye. This is Ray. Rays go on forever in one direction. I had a student named Ray last year. The kid's a legend. Ray, if you're watching, and I know you are, hi. Stop bringing me eggs. I don't know why this kid brought me eggs, but he did. We had a pie eating contest in school. Ray ate the pie, and then he ate the other pie. He was only supposed to eat one. He puked. He kept going. His face was covered. He was allowed to use his hands, but he didn't. They had to call the pie eating contest off. He wins. He wins. No more. Make it stop. He didn't. Legend. Hi, Ray. I miss you. All right. A portion of the line that starts at a point, the end point, and continues forever in one direction. Notice direction matters. This is not Ray QP. It's Ray PQ. We're going from P to Q. Direction matters here. Coplanar, parallel, and collinear. Co means together, like co-eds, right? I got your interest. Coplanar, planar, right? So they're on the same plane. It's what happens when you share the same floor with people, right? I went to Wesleyan, it's a university, please don't go there, and they had the girl dorm and the guy dorm, and they're connected by a lounge in the middle, right? We were coplanar, right? Infinite length, infinite width, okay. Parallel. Parallel means they never intersect, which is not what happened in those dorms. Collinear. Co means together, linear means line. So when you're on the same line, right? We talked about heroin, cocaine is bad too. Got that one. That's good. You guys are all very pure. All right, postulate. I'm serious about that. Like, there are drugs and then there's drugs. Don't do cocaine, don't do heroin. Seriously. All right, too many friends. This is a serious thing. Too many friends have really had bad stuff happen to them. A postulate. Okay, so you know what theorems are, right? Theorems are things that are proven, which is confusing because, like, in science, theory is like just an idea that's really well supported but not proven. Well, a theorem is proven. A postulate is what builds into those theorems. Because at some point, you can't prove everything. Right? You got to take a leap of faith at some point. This is a very spiritual thing, okay? There are foundational postulates in geometry, things that we have to accept to be true. Here's the first one we're going to learn about today. It's the segment addition postulate. This is the building blocks upon which we are going to build all of our theorems, all the things that we know to be true, and we can prove them. This is not provable. It just is. You just know it in your heart it has to be, okay? Let A, B, and C be collinear points. What does it mean to be collinear? Collinear. Co means together, right? Co-eds? What is on the same line? Yeah, right? So A, B, and C are collinear. Here we go, all on the same line. We're going to let that be, like the Beatles. If B is between A and C, oh good, I did it right. Always read the directions. Then AB, that's this, right? That's AB, plus BC. We don't need the line above this if we're talking about how long it is, the value, right? It is a segment. The whole thing is AC. So it's saying that if you add AB and BC together, you get AC. Can you prove this? No, it's a postulate. We just know it to be true. How can it be anything else? We assume this to be true. We know what assuming does to us. It makes it and, right? But this is safe. It's a postulate. Ta-da! What do you think about that? Good, wonderful, excellent. So here's what we're going to do. I'm going to pass out the homework. You're going to get started. It's all about the segment addition postulate. It's so easy, right? You guys are like, oh, this is boring. Segment addition postulate. AB plus BC equals AC. I can do it in my sleep. We'll find out. Here we go. This is one of my least favorite assignments to give out. It's 10 whole questions long. I apologize for that. And I know. Here you go. There is a typo on the second page. We're going to walk you through that. It'll be all right. I know, today, right? Here we go, here we go, here we go. Is anyone else disappointed that I didn't have Snorlax in that Pokemon list?
Yeah.
Everybody's like, Snorlax is fat. But you know what? Snorlax is more than fat. Snorlax is nice. There are a lot worse things to be than fat, right? Snorlax is kind. But he didn't make my list. All right, so everybody have homework. A worky sheet.
Yeah.
Well, thank you for your response. All right, so take a look. The idea is you're going to find the length of the missing segment using the segment addition postulate. Now, it's called the segment addition postulate, but don't be afraid to subtract, right? Addition and subtraction is the same thing, just two different sides of the coin, right? So they want you to find what HG is here. So HG, its value. Again, when we're talking about the value, we don't need the line over the top. I know it's a segment. We're going to answer that question. Well, the whole dumb thing is 10, right? So HF is 10. If GF is 1, what's the length of HG? 9. 9! It's a German for no. All right, so that's the idea here. So the whole thing is 32. Find that little bit, right? Now, if you get further down, we have a little more craziness going on here. We've got multiple dots. If you want to add in a dot there where it says B and E for number 4, those dots are missing. I apologize. The idiot that I stole this from did not do it correctly. Normally I make all these by scratch, but last night I was just too preoccupied to do that. And I was like, treat yourself, Derek. Treat yourself. Go get a Casey's Pizza. Don't do anything tonight. Just chill. You guys watch Parks and Rec? No? Tommy Fresh? Apps and Zerts? All right, we're going to have a movie day in here. All right, so we know that DB is 30, and we know that the whole dumb thing is 49. They want you to find EC. Now notice EC is this little bit right here. And by little bit, I mean these two bits. So make sure you answer that question. What do you know about EC, just based off the diagram? It has to be bigger than what? It has to be bigger than 16, right? Because it's 16 plus something. Turn the page. Points A, B, and C are collinear. Draw a line, A, B, and C. Put them on there. If AB, no, shouldn't say if. Find AB. If BC is 9 and AC is 13. B is in the middle, by the way. Order matters. Keep going down the page. You're going to have to do something with X and variables, okay? These are the hard ones. Best of luck on it. I'll see you guys tomorrow. We'll grade this in class. If you don't like your grade, remember we turn it in on Friday because it's just a rough draft. See you tomorrow, nerds.
Bye.
Bye. What?
What is this for?
The graph paper?
Yeah.
It was for you, man. It was just for you. If you wanted it. I'll upload this tonight.